the job has significant wiring issues that need attention. Dishwashers and dryers should be on separate home runs. Using a switch tap to power a disposal and dishwasher is a code violation. Bedroom and hallway switches must be wired independently. If the job was passed during a rough inspection, these listed code violations should have been caught. Begin with the rough inspection report. Review the inspector's notes to identify any issues that were previously identified. Then thoroughly inspect the wiring. Check all circuits for proper wire sizing, routing, and connections. Next, identify and correct code violations. Fix all of the issues discovered and any others that are found. Communicate with the inspector. Inform the inspector of the code violations that have been discovered and the corrective actions taken. The 1999 code does not provide a loophole to avoid arc fault protection. The inspector has the authority to enforce current code requirements. Dining room circuits can be separate or shared with other areas, as long as they meet the load requirements. Document the code violations. Take notes and photographs of any issues that are identified. Discuss any concerns with the supervisor. Explain the violations that have been discovered and the need to address them. Provide documentation to support the claims. Present the inspector's report and personal findings to support the position. Prioritize code compliance. Emphasize the importance of ensuring safety and meeting code requirements. Offer solutions to address the violations, such as rewiring or installing arc fault circuit interrupter breakers. It is important to ensure that dishwashers and dryers are on separate circuits because they are high-demand appliances. Putting them on the same circuit can overload the circuit, causing the breaker to trip or potentially creating a fire hazard. National Electrical Code, or NEC, mandates dedicated circuits for these appliances to ensure safe operation. Tapping into a switch for disposal and dishwasher power is a code violation because switches are not designed to handle the continuous load of these appliances. This practice can overheat the switch and create a fire hazard. Instead, these appliances should be powered by dedicated circuits that are properly sized for their load. Bedroom and hallway switches should be wired independently to provide proper control of lighting in these areas. Interconnecting these switches can create confusion and make it difficult to control the lighting. Each area should have its own set of switches that control only the lights in that area. If the code violations were not caught during the rough inspection, it indicates a failure in the inspection process. A thorough rough inspection should identify any wiring issues that need to be corrected before the wiring is covered up. It is important to communicate these findings to the inspector and ensure that they are addressed before proceeding with the job. When beginning a job where someone else has started the wiring, it is important to start with a thorough inspection of the existing wiring. This includes checking for proper wire sizing, routing, and connections. It also includes verifying that all circuits are properly grounded and that all devices are properly installed. It is important to identify and correct any code violations before proceeding with the job. The 99 code does not provide a loophole to avoid arc fault protection because arc fault circuit interrupter breakers are designed to protect against electrical fires caused by arc faults. An arc fault is a dangerous electrical condition that can occur when damaged or deteriorated wiring creates an unintended electrical path. Arc fault circuit interrupter breakers are designed to detect these arc faults and trip the circuit, preventing a fire. Inspectors have the authority to enforce current code requirements because they are responsible for ensuring that all electrical work meets the minimum safety standards. They have the authority to require that any code violations be corrected before the job is approved. Dining room circuits can be separate or shared with other areas as long as they meet the load requirements. The National Electrical Code specifies the minimum number of circuits required for a dwelling unit based on the square footage of the dwelling and the number of appliances. The dining room circuit must be able to handle the load of any appliances that are used in the dining room, such as a refrigerator, microwave, or toaster oven. Documenting code violations is important because it provides a record of the issues that were identified and the corrective actions that were taken. This documentation can be helpful in resolving any disputes with the supervisor or the inspector. It is also important to take photographs of any code violations to provide visual evidence of the issues. Discussing concerns with the supervisor is important because it allows to communicate the findings and work together to find solutions. It is important to explain the violations that have been discovered and the need to address them in order to ensure safety and meet code requirements. Providing documentation to support claims is important because it provides evidence to back up the findings. The inspector's report and personal findings can be used to support the position that the code violations need to be corrected. Prioritizing code compliance is important because it ensures that the electrical work meets the minimum safety standards. Electrical codes are designed to protect people and property from electrical hazards. By complying with the code to ensure that the electrical system is safe and reliable. Offering solutions to address the violations is important because it shows the supervisor that it is committed to finding solutions to the problems. Rewiring or installing arc fault circuit interrupter breakers are just two of the possible solutions that can be used to address the code violations. In addition to the specific code violations mentioned, there are other general electrical safety practices that should be followed. Always turn off the power before working on any electrical circuits. Use properly insulated tools and equipment. Never work on electrical circuits in wet or damp conditions. If you are not comfortable working on electrical circuits, hire a qualified electrician. Wire sizing is a critical aspect of electrical installations that ensures safety and prevents overheating or fire hazards. The National Electrical Code, or NEC, provides tables that specify the appropriate wire size for different amperage ratings and insulation types. These tables take into account the ampacity of the wire, which is the maximum amount of current that the wire can safely carry. Factors such as the ambient temperature, the number of conductors in a raceway, and the type of insulation also affect the wire size requirements. It is important to consult the NEC tables to determine the correct wire size for each circuit to ensure that it can handle the expected load. Proper wire routing is also important for electrical safety and code compliance. Wires should be routed in a neat and organized manner, avoiding sharp bends and avoiding contact with sharp objects or hot surfaces. Wires should be supported at regular intervals to prevent them from sagging or becoming damaged. Wires should also be protected from physical damage by using conduit, tubing, or other protective measures. Proper connections are essential for ensuring reliable electrical service and preventing overheating or arcing. All connections should be made using approved connectors or terminals, and they should be tightened to the proper torque specifications. Wire nuts, for example, should be properly sized for the number and size of the wires being connected, and they should be twisted tightly to ensure a secure connection. Loose or corroded connections can cause resistance, which can lead to overheating and potentially a fire. Grounding is a critical safety feature that provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. All electrical circuits and equipment should be properly grounded in accordance with the NEC requirements. The grounding system typically consists of a grounding electrode, such as a ground rod or a metal water pipe, and a grounding conductor that connects the equipment to the grounding electrode. The grounding conductor should be properly sized and connected to all metal enclosures, equipment frames, and other conductive parts that could become energized in the event of a fault. Device installation is also important for electrical safety and code compliance. All devices, such as switches, receptacles, and lighting fixtures, should be installed in accordance with the manufacturer's instructions and the NEC requirements. Devices should be securely mounted and properly connected to the wiring. Devices should also be protected from physical damage and moisture. If there are any doubts about how to install a device properly, it is best to consult with a qualified electrician. Verifying proper grounding is essential for ensuring electrical safety. Grounding provides a low resistance path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. To verify proper grounding, use a multimeter or a ground tester to measure the resistance between the grounding conductor and the grounding electrode. The resistance should be low, typically less than 5 ohms. If the resistance is high, it indicates a problem with the grounding system that needs to be corrected. Identifying code violations is a crucial step in ensuring electrical safety. Code violations can create hazards that could lead to electrical shock, fire, or other injuries. It is important to be familiar with the NEC requirements and to be able to identify common code violations such as improper wire sizing, improper grounding, and improper device installation. If any code violations are identified, they should be corrected immediately. Arc fault circuit interrupter breakers, or arc fault circuit interrupter, are designed to protect against electrical fires caused by arc faults. An arc fault is a dangerous electrical condition that can occur when damaged or deteriorated wiring creates an unintended electrical path. Arc fault circuit interrupter breakers are designed to detect these arc faults and trip the circuit, preventing a fire. Arc fault circuit interrupter breakers are typically required in bedrooms, living rooms, and other areas where people are likely to be present. Understanding the authority of the inspector is crucial for ensuring code compliance. Inspectors are responsible for enforcing the electrical codes and ensuring that all electrical work meets the minimum safety standards. They have the authority to require that any code violations be corrected before the job is approved. It is important to cooperate with the inspector and to address any concerns that they may have. Meeting load requirements is essential for ensuring that the electrical system can handle the expected load. The National Electrical Code specifies the minimum number of circuits required for a dwelling unit based on the square footage of the dwelling and the number of appliances. The circuit must be able to handle the load of any appliances that are used in the circuit. It is important to calculate the load requirements for each circuit and to ensure that the circuit is properly sized to handle the load. Providing visual evidence is a strong way to back up any claims. The inspector's report and personal findings can be used to support the position that the code violations need to be corrected. Visual evidence can also be used to demonstrate the severity of the code violations and the potential hazards that they create. Electrical codes are designed to protect people and property from electrical hazards. By complying with the code, you can ensure that the electrical system is safe and reliable. The electrical codes are constantly being updated to reflect new technologies and new safety concerns. It is important to stay up to date on the latest code requirements to ensure that electrical work is in compliance with the current standards. If not confident in the electrical skills, hire a qualified electrician for the job. Electrical work can be dangerous, and it is important to have the necessary skills and knowledge to perform the work safely. If not comfortable working on electrical circuits, hire a qualified electrician. It is important to consult the National Electrical Code, or NEC, which is a comprehensive set of standards that govern electrical installations in the United States. The NEC is updated every 3 years, and it is important to stay up to date on the latest code requirements to ensure that electrical work is in compliance with the current standards. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. The NEC also provides guidance on how to calculate the load requirements for electrical circuits and how to select the appropriate wire size for each circuit. In addition to the NEC, there may be local electrical codes that apply. Local electrical codes are typically based on the NEC, but they may have additional requirements that are specific to the local area. It is important to check with the local electrical inspector to determine what local codes apply. There are many resources available to help one learn more about electrical codes and electrical safety. The National Fire Protection Association, or NFPA, offers a variety of training courses and publications on electrical safety. The International Association of Electrical Inspectors, IE, also offers training courses and publications on electrical codes. Many community colleges and technical schools offer electrical apprenticeship programs that provide comprehensive training in electrical theory and practice. It is also possible to learn about electrical codes and electrical safety online. The NEC website provides access to the full text of the NEC, as well as a variety of other resources. There are also many online forums and discussion groups where you can ask questions and get help from other electricians and electrical professionals. The importance of ongoing education and training in the electrical fields cannot be overstated. Electrical codes are constantly evolving and new technologies are constantly being developed. It is important to stay up to date on the latest developments in the electrical field to ensure the skills and knowledge are current. Ongoing education and training can also help to advance career and increase earning potential. In addition to formal training courses, there are many other ways to stay up to date on the latest developments in the electrical field. Attend industry conferences and trade shows to learn about new products and technologies. Read trade publications and online articles to stay informed about the latest code changes and best practices. Network with other electricians and electrical professionals to share knowledge and experience. By staying up to date on the latest developments in the electrical field, the ability to provide the best possible service to customers and ensure electrical installations are safe and reliable. The NEC has specific requirements for bathroom circuits to enhance safety in these moisture-prone areas. Firstly, at least one 20-amp circuit is required to serve bathroom receptacle outlets. Secondly, this circuit cannot serve any other outlets outside of the bathroom. Thirdly, all 125-volt, 15 and 20-amp receptacles in bathrooms must have ground fault circuit interrupter protection. This protection is designed to prevent electrical shock in damp locations. Finally, lighting and ventilation equipment can be on a separate circuit. The goal is to isolate bathroom circuits to minimize risks associated with water and electricity. For kitchen circuits, the NEC provides detailed guidelines to manage the higher electrical demands of kitchen appliances. Firstly, at least two 20-amp small appliance branch circuits are required to serve receptacle outlets in the kitchen, pantry, breakfast room, and dining room. Secondly, these circuits should not serve lighting outlets. Thirdly, countertop receptacles should be placed so that no point along the countertop is more than 24 inches from a receptacle. Furthermore, island and peninsula countertops also have specific receptacle placement requirements. Finally, at least one separate 20-amp circuit must be provided for the refrigerator. These rules ensure that kitchen appliances can operate safely without overloading circuits. Living room circuits generally have fewer specific NEC requirements compared to kitchens and bathrooms, but some best practices enhance safety and convenience. Firstly, receptacles should be spaced so that no point along the wall is more than 6 feet from a receptacle. Secondly, consider using arc fault circuit interrupter protection for living room circuits to protect against electrical fires. Thirdly, ensure that lighting is adequate for the room's size and use, and consider using dimmer switches to adjust the lighting level. Lastly, avoid overloading circuits with too many devices or appliances. Proper planning ensures a safe and functional living room electrical system. For bedroom circuits, the NEC emphasizes safety to protect occupants while they sleep. Firstly, arc fault circuit interrupter protection is typically required for bedroom circuits to prevent electrical fires. Secondly, receptacles should be spaced so that no point along the wall is more than 6 feet from a receptacle. Thirdly, smoke detectors are required in each bedroom and should be interconnected so that if one alarms, they all alarm. Furthermore, carbon monoxide detectors may also be required depending on local codes. Finally, ensure that lighting is adequate for reading and other activities, and consider using dimmer switches. These measures help create a safe and comfortable bedroom environment. Hallway circuits are essential for providing safe passage throughout a building. Firstly, hallways at least 10 feet long require at least one receptacle outlet. Secondly, lighting should be adequate to illuminate the hallway and prevent tripping hazards. Thirdly, consider using occupancy sensors to automatically turn on the lights when someone enters the hallway. Furthermore, ensure that switches are conveniently located at each end of the hallway to allow for easy control of the lighting. Finally, avoid overloading hallway circuits with too many devices or appliances. Well-designed hallway circuits enhance safety and convenience. Outdoor circuits require special attention to protect against the elements. Firstly, all outdoor receptacles must have ground fault circuit interrupter protection to prevent electrical shock in wet conditions. Secondly, use weather-resistant receptacles and covers to protect against rain, snow, and ice. Thirdly, bury underground wiring at the proper depth and protect it with conduit. Furthermore, outdoor lighting should be weather-resistant and properly installed. Finally, consider using a timer or photocell to automatically control outdoor lighting. Careful planning ensures that outdoor circuits are safe and reliable. For dining room circuits, the NEC has specific requirements to address the needs of this area. Firstly, dining rooms must be included when calculating the number of small appliance branch circuits required for kitchens and dining areas. Secondly, receptacles should be spaced so that no point along the wall is more than 6 feet from a receptacle. Thirdly, consider using arc fault circuit interrupter protection for dining room circuits to protect against electrical fires. Furthermore, lighting should be adequate for dining and other activities, and consider using a dimmer switch to adjust the lighting level. Finally, avoid overloading dining room circuits with too many devices or appliances. Proper dining room circuits provide safety and convenience. Electrical panels serve as the central distribution point for electricity in a building. Firstly, a panel should be properly sized to accommodate the current and future electrical need. Secondly, all circuits should be clearly labeled to identify what they serve. Thirdly, there should be adequate working space around the panel for safe access. Furthermore, the panel should be located in an accessible location and protected from physical damage. Finally, it is important to periodically inspect the panel for any signs of damage or overheating. A well-maintained electrical panel ensures safe and reliable electrical service. Grounding systems are essential for protecting against electrical shock and preventing electrical fires. Firstly, the grounding system must be properly installed and connected to a grounding electrode, such as a ground rod or metal water pipe. Secondly, all metal enclosures and equipment frames should be grounded. Thirdly, grounding conductors should be properly sized and connected to the grounding system. Furthermore, it is important to periodically inspect the grounding system for any signs of damage or corrosion. Finally, test the grounding system to verify that it is functioning properly. A properly installed and maintained grounding system provides critical safety protection. The National Electrical Code, or NEC, is a comprehensive set of standards that govern electrical installations in the United States. Firstly, the NEC is updated every 3 years, and it is important to stay up to date on the latest code requirements. Secondly, the NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. Thirdly, the NEC provides guidance on how to calculate the load requirements for electrical circuits and how to select the appropriate wire size for each circuit. Furthermore, the NEC is adopted by most states and local jurisdictions, and it has the force of law. Finally, it is important to consult the NEC whenever performing electrical work to ensure that it is done safely and in compliance with the code. The National Electrical Code Section 310.15 covers ampacity tables for conductors, providing essential guidelines for safe and efficient electrical wiring. These tables list the maximum current, measured in amps, that conductors of various sizes and insulation types can carry continuously under specific conditions without exceeding their temperature rating. To effectively use these tables, several factors must be considered. Firstly, the type of conductor insulation, such as THHN, THHW, or XHHW, as each has different temperature ratings and ampacity values. Secondly, the ambient temperature, as higher temperatures reduce the ampacity of conductors. Thirdly, the number of current-carrying conductors in a raceway or cable, as multiple conductors bundled together can increase heat and reduce ampacity, requiring adjustment factors. Furthermore, the tables differentiate between copper and aluminum conductors, each having different ampacity characteristics. Finally, it's crucial to apply the appropriate correction and adjustment factors as specified in the NEC to ensure accurate ampacity calculations and safe installations. The NEC Section 250 provides comprehensive requirements for grounding and bonding, which are critical for electrical safety. Grounding ensures a low impedance path for fault currents, allowing overcurrent protection devices to quickly clear faults and minimize the risk of electrical shock. Bonding connects non-current carrying metal parts to create an electrically conductive path, further reducing shock hazards. Key aspects of this section include firstly, the proper installation of grounding electrodes, such as ground rods, metal water pipes, or concrete encased electrodes. Secondly, the sizing and routing of grounding and bonding conductors to ensure effective fault current flow. Thirdly, the bonding of metal enclosures, raceways, and equipment to create a continuous electrical path. Furthermore, the section addresses specific grounding requirements for different types of systems, such as separately derived systems and services. Finally, compliance with NEC 250 is essential for maintaining a safe and reliable electrical system. The NEC section 210 covers branch circuits, which are the circuits that supply power to outlets, lighting, and appliances. This section outlines requirements for the number, type, and loading of branch circuits to ensure safe and reliable power distribution. Key provisions include firstly, the minimum number of branch circuits required based on the square footage of the building and the types of loads served. Secondly, the permissible loads on each circuit, including general purpose circuits, small appliance branch circuits, and individual branch circuits. Thirdly, the requirements for receptacle outlets, including spacing, location, and ground fault circuit interrupter protection. Furthermore, the section addresses specific requirements for branch circuits in dwelling units, such as kitchens, bathrooms, and bedrooms. Finally, compliance with NEC 210 is essential for providing adequate and safe power to all parts of a building. The NEC section 408 addresses switchboards and panel boards, which are critical components in electrical distribution systems. This section outlines requirements for the construction, installation, and protection of these devices to ensure safe and reliable operation. Key provisions include firstly, the proper sizing of panel boards based on the connected load and future expansion needs. Secondly, the overcurrent protection requirements for each circuit in the panel board. Thirdly, the labeling requirements for circuits and components. Furthermore, the section addresses specific requirements for working clearances, access, and protection from physical damage. Finally, compliance with NEC 408 is essential for maintaining a safe and well-organized electrical distribution system. The NEC section 110 provides general requirements for electrical installations, covering a wide range of topics to ensure safety and compliance. Key provisions include firstly, the approval of equipment and materials used in electrical installations. Secondly, the proper installation and use of electrical equipment in accordance with manufacturer's instructions. Thirdly, the requirements for working clearances around electrical equipment for safe access and maintenance. Furthermore, the section addresses issues such as guarding of live parts, identification of conductors, and protection against physical damage. Finally, compliance with NEC 110 is essential for establishing a foundation of safety and quality in all electrical installations. Overcurrent protection is a critical safety feature in electrical systems, designed to protect conductors and equipment from damage caused by excessive current. Overcurrent devices such as circuit breakers and fuses are designed to automatically interrupt the flow of current when it exceeds a predetermined level. The selection and sizing of overcurrent devices must be carefully coordinated with the ampacity of the conductors and the rating of the equipment being protected. The NEC provides detailed guidelines for overcurrent protection in section 240, covering topics such as standard ampere ratings, conductor protection, and specific requirements for different types of equipment. Proper overcurrent protection is essential for preventing overheating, fires, and other hazards associated with electrical faults. Wiring methods refer to the techniques and materials used to install electrical conductors in a building. The NEC recognizes a variety of wiring methods, each with its own advantages and limitations. Common wiring methods include firstly, rigid metal conduit, or RMC, which provides excellent protection against physical damage and is suitable for both indoor and outdoor applications. Secondly, electrical metallic tubing, or INT, which is lighter and easier to install than RMC, but provides less physical protection. Thirdly, non-metallic sheath cable, or NM cable, which is commonly used for residential wiring and is relatively inexpensive. Furthermore, flexible metal conduit, or FMC, which is used for short runs and connections to equipment where flexibility is needed. Finally, each wiring method has its own specific requirements for installation and support, as outlined in the NEC. Proper selection and installation of wiring methods is essential for ensuring a safe and reliable electrical system. Ground fault circuit interrupters, or GFCIs, are life-saving devices designed to protect people from electrical shock. GFCIs monitor the current flowing in a circuit and quickly interrupt the power if they detect a ground fault, which is a leakage of current to ground. GFCIs are required in areas where there is a high risk of electrical shock, such as bathrooms, kitchens, and outdoor locations. The NEC requires ground fault circuit interrupter protection for receptacles in these areas to provide an additional layer of safety. GFCIs are available in various forms, including receptacle type, circuit breaker type, and portable type, and they should be tested regularly to ensure that they are functioning properly. Arc fault circuit interrupters, or arc fault circuit interrupter, are devices designed to protect against electrical fires caused by arc faults. An arc fault is an unintentional electrical discharge that can occur when damaged or deteriorated wiring creates an unintended electrical path. Arc fault circuit interrupter breakers are designed to detect these arc faults and trip the circuit, preventing a fire. Arc fault circuit interrupter breakers are typically required in bedrooms, living rooms, and other areas where people are likely to be present. The NEC requires arc fault circuit interrupter protection for branch circuits in these areas to provide an additional layer of fire protection. Electrical bonding is the process of connecting non-current carrying metal parts together to create an electrically conductive path. Bonding is essential for electrical safety because it helps to equalize the voltage potential between different metal parts, reducing the risk of electrical shock. Bonding is typically achieved by connecting metal parts with bonding jumpers or bonding conductors. The NEC provides detailed requirements for electrical bonding in Section 250, covering topics such as bonding of metal enclosures, equipment frames, and piping systems. Proper electrical bonding is essential for maintaining a safe and reliable electrical system. Surge protection devices, or surge protective devices, are designed to protect electrical equipment from voltage surges, which are temporary spikes in voltage that can damage or destroy electronic components. Voltage surges can be caused by lightning strikes, power outages, or other electrical disturbances. Surge protection devices work by diverting the excess voltage away from the protected equipment and safely to ground. Surge protection devices are available in various forms, including whole-house surge protectors, which protect the entire electrical system, and point-of-view surge protectors, which protect individual devices. The NEC recommends the use of surge protection devices to protect sensitive electronic equipment. Electrical lockout/tagout procedures are safety practices used to prevent accidental energization of electrical equipment during maintenance or repair. These procedures involve disconnecting the equipment from its power source and applying a lockout device, such as a padlock, to prevent the circuit breaker or disconnect switch from being turned on. A tag is also attached to the lockout device to warn others not to energize the equipment. Electrical lockout/tagout procedures are required by Occupational Safety and Health Administration, or OSHA, and are essential for protecting workers from electrical hazards. Electrical safety audits are systematic reviews of electrical systems and practices to identify potential hazards and ensure compliance with safety standards. Electrical safety audits can be conducted by internal personnel or by external consultants. The audit typically involves a visual inspection of the electrical system, a review of safety procedures, and interviews with employees. The findings of the audit are documented in a report, which includes recommendations for corrective action. Regular electrical safety audits are essential for maintaining a safe and compliant electrical work environment.